Hi there. In this demonstration, we're going to learn how to conduct an ANOVA test, or specifically a one-way ANOVA test with SPSS. And we're just going to use the oversimplified examples that were demonstrated in Chapter 11.3, where we actually calculated the test statistics, the variance between groups, the variance within groups. And so there isn't really a story problem that goes along with this. It's just three different samples. In the first case, the three samples have similar means, and these are they're not measuring anything particular. It's some sort of quantitative data. And when we did this, when we calculated our test statistic by hand, we got a test statistic of 2.73, a p-value of 0.106. That was too big. So we failed to reject the null hypothesis. The null hypothesis is that the population means are all equal. So we failed to reject that, and we say there's not enough evidence to conclude that the population means are not equal. And the second case, it looks a lot like the first case, only this third sample, the numbers are a lot higher, thus giving it a higher mean, and it gives us a much greater test statistic and a much smaller p-value. In this case, regardless of the significance level, we're going to be rejecting the null hypothesis, and there is sufficient evidence to conclude the population means are not equal. Right? So we're going to do this in SPSS, and it's very easy, but as the case with SPSS, the trick is getting the data in the appropriate format. Right? And so SPSS likes data in this form, right, where each row represents a case, right? So what I mean by that, if you look at these three samples up here, and this is the way it's usually put in, say, a textbook, because it saves a lot of space, right? But in a data file, it won't necessarily be in this format. So what I have here are 15, there's 5 scores from each sample, so there are 15 different cases. For each case, it's categorized into which sample it came from and what score is, right? And so what that looks like in standard data format is 2 columns, right? The sample represents which sample the data came from. So there's 3 values for that because there's 3 samples. And then the actual score, all right? So once you get it set up in that format, the ANOVA test, it's just a couple of button clicks away. So I did that, and so what we'll do is we'll shrink this down. We'll go over to SPSS. Let me move this out of the way, but not gone. All right, and we'll do the first case where the means are similar. All right, and so here's the data in that format. All right, that's the sample. Which sample does it come from? And that's the score. Right, and just to make sure, we're going to go to our variable view and check the format of our data. The sample number, it is numeric. You could actually make that string if you want. It doesn't make much difference. But I like to leave it numeric because it is actually a number. But the fact is the number doesn't really hold much meaning numerically speaking. It's just a label for which sample. So it gets the level of measurement nominal, which goes along with qualitative data. The score, that is actually legitimate numerical data. And so we give that a measurement level of scale, which is for ratio and interval data levels. All right, good. Once our data is all set up, we just go to Analyze. We're looking to compare means here. We have 3 different samples, but we're still looking just for comparing means. And when we do that, ANOVA is right down there at the bottom. One-way ANOVA, right? Because there's only one type of variable that we're changing. So one way, and the factor will be the sample, right? So there's only one factor in there. That's what makes it a one-way. And then score, that'll be the dependent, right? Now we're going to click OK. It's going to work on it for a little while. Very quick, easily done. 2.7. So you go down here, the F test statistic is 2.727. That is what we got over here when you round it to 3 decimals. The p-value is right here. That sig represents the significance of the test statistic, right? And so 0.106 is just the p-value, right? The significance of the test statistic is another name for the p-value. So you get a p-value of 0.106. That's what we got when we worked this out in the textbook by hand. Right? And it also, in the textbook, we also went and calculated the variance between groups and the variance within groups, which in this context they call the mean square between groups, within groups, and we got those same values. Right? So, and doing it by hand was, you know, if you did read that page or we went over it in class, it's a lot of work. So it's nice to have SPSS do that for you. So now if we go to the disparate means, where the first two samples are actually the same, the third sample has a higher mean. And so that's in this data set here. Again, I have 3 samples, 1, 2, and 3, and these are the scores. Right? Those are the 5 from sample 1, the 5 from sample 2, and then the 5 from sample 3. Right? And so I'm going to go to Analyze, Compare Means, right? One-way ANOVA, and the factor is the sample, right? One of the 2, 3 factors, and then the score, and it's one of the 3 samples, not one of the 3 factors. There's only one factor, right? There are 3 samples. Okay, so when I hit OK, taking a little bit of time here, let's preview what we're looking for. In the book, we calculated a test statistic of 28.18. That's pretty big. That's because this mean was so much higher than the others, and my variance between groups got very large. And my p-value is hence very small, 0.00029, which SPSS will probably, and in fact did, round to 0.00, because it rounds to 3 decimals. So here's the output from SPSS. Again, the test statistic, 28.182. That's what we got when rounded to 2 decimals. The significance of the test statistic, also known as the p-value, is 0.00, which in this case, if you round 0.000029 to 3 decimals, you get 0.00. I'm not a big fan of SPSS doing that because it's not really 0. All right, it's less than 0.0005 in order to round to that value. But assuming you know what you're doing, you will know that the significance is actually not 0. And again, what you notice is that the variance, or the mean square between groups, is just so big, and that's what causes the big test statistic and the small p-value. So in that case, we're going to reject the null hypothesis, and the null hypothesis is that the populations from which these samples came all have the same mean. So we basically have sufficient evidence to conclude that those population means are not equal. All right, so ANOVA with SPSS, it's a couple button clicks once you get your data into the proper format. And that really is the case with SPSS all the way around. Once you get, getting the data in the proper format and sort of cleaning it up, that takes a lot of time. So if you find that you're spending a lot of time, more time than you would like, just getting the data into the appropriate format, you're probably doing it right, because that is the time hog. Once you have it all set up, just clicking some buttons and having SPSS run the analysis. That's fast. That's easy. Yeah, the work is in getting the data properly formatted. And so that wraps it up. We have SPSS ANOVA, or one-way ANOVA in this case. And bye.